Hello everyone, my name is Malfi. Today I will present my homework 3. First, let's look at our main goal. We need to control square steel and pieces with a PLC. The process is simple. The steel pieces come from a gravity manage. That means they slid down by themselves, then go to a drilling machine. After that, they are clamped, drilling, and finally ejected. The key actions we need to control are marked as 1A plus, 2A plus, 2A reduce, 1A reduce, 3A plus, 3A reduce. Later, I will explain what each action does step by step. Now let's understand where this system works and why it's useful. Secure reposition. This system is part of workplace processing and governing. In discrete manufacturing means we make separate products like these square steel pieces one by one. Our goal here is to let the square steel drilling process run without people. Unmanned operation. Task value. How do we make this work? We use two things. Pneumatical parts that use air pressure, and electronic control. Together, they make sure three key steps: clamping, meshing, draining, and ejecting are accurate and stable. This helps two big things: make production faster, improve efficiency, ensure every steel piece is processed the same way, improve consistency. To move the steel pieces and tools, we use a pneumatic system. Let's talk about the three main parts. First, we use double acting cylinder. How do they work? Air goes into two different chambers, one after another. This makes the cylinder extend, push out, and retract, pull back. It has two good heights. The pushing force is stable. It responds quickly, perfect for our drilling steps. Second, this is like a switch for air. We use double electronic control directors levers. For example, Y1 and Y2 control the 1A action. When the lever gets power, it changes the airflow direction. When it loses power, it stays in the correct state. This makes the system reliable. No sudden change. Third, this part checks where the circulator is. We use magnetic proximate switches like A0, A1, B0, B1. It works without touching the circulator, so it lasts a long time and isn't easily disturbed by other things. It tells the control circuit where the regulator is. which is very important for accurate control. Let's see how air flows when we do the 1A plus action. Compressed air goes into the container release chamber through port 4 of the soldered valve. This pushes the piston to extend 1A plus. The used air in the road chamber comes out through port 2 of the valve and exits the system. The logic here is simple. The soldered valve is the core. When one Y1 gets power, we have 1A plus. When Y2 gets power, we have 1A reduced. And the proximate switches A1 and A0 tell us when to stop. They are the trigger to end the action. Now let's talk about the electronic side. It's like the brain of the system. We spread it into 3 layers. First, power layer. We use 24 DC power for the control circuit, and the 0Y is the common wire. This power makes sure all ports like relay and the switches can work and set signals. Control layer. We have 3 relays, K1, K2, K3. They are like middlemen. For logical, each relay has two types of contacts, normally open and normally closed. By combining these contacts, we make sure actions don't conflict and happen in the right order. 3. Executes layer. This layer does the actual working. Slow the valve close, gets control signals and changes the airflow. Proximity switches. Turn medical piston into electronic signals, power on or off. They are key for making actions happen in sequence. Let's start with the first action, 1A plus. The first cylinder exercitates. Let's break down the electronic logic. First, when we press the start button, it contact close. Then 24-volt power flows to relay K1 core, but it only flows if 3 things are true. K1 normally closed, contact is closed. C0 normally closed, contact is closed. B1 normally closed, contact is closed. When all 3 are true, K1 gets power. 2. Action triggers. When K1 is poured, it normally open, contact closed. Now 25-volt flows to solid vehicle Y1. Y1 gets power, so we have the 1A plus action. This continues until the proximity switch A1 is triggered. A1 is contact closed. This tells us 1A plus is done and get ready for the next step. 3. To keep the system safe. When K1 is poured, it normally closed contact open. This means 1A plus and 1A reduce can't happen at the same time. See there, the normally closed contact, make sure the system only start when it's in the intended position, so we avoid damage from starting with parts in the wrong place. Next action, 2A plus. When does this start? First, Tanger condition. After 1A plus finished, the proximity switch A1 is target. Now 24 white flows to relay K2 core, but only if K2 normally closed contact is closed. Then K2 get power. 2. Action tagging. When K2 is powered, it normally open contact closed. 24 white flows to solid with core Y3. Y3 gets power, so we have the 2A plus action. This stops when proximity switch to B1 is triggered. 3. Logical leak. A1 is the signal to go from 1A plus to 2A plus. It makes sure 2A plus starts only after 1A plus is done, and K2 normally closed contact makes sure 2A plus doesn't start by mistake before its time. Now 2A reduce. Let's see. First, trigger condition when 2A plus finish proximity switch to B1 is triggered. Now 24 white directly flows to value core Y4. No relay in between. Y4 gets power, so we have 2A reduced action. 2. Action termination. When 2A reduce finish proximity switch C1 is triggered. This doesn't stop the action directly. It gets the system ready for the next step when A reduce. 3. Design detail. Why no relay? Because we want to switch from 2A plus to 2A reduce to be fast. This keeps the processing flow tidy and effective. Next, 1A reduce. Trigger condition after 2A reduce finish. Proximity switch C1 is triggered. 24 directly flows to solid variable Y2. Y2 gets power, so we have 1A reduced action. 2. Action termination. When 1A reduced finish, proximity switch D1 is target. This gets the system ready for the next action, 3A plus. Logical closed loop. 1A is the reverse of 1A plus. C1 is the branch between 2A reduce and 1A reduce. It makes sure the steel pulse is put back to the right position after dealing. Now 3A plus, this is for eject the finished steel pulse. When after 1A reduce finish, prod meeting, switch D1 is target. 24 white flows to rely K3 core only if K3 normally closed contact is closed. Then K3 gets power. 2. Action tagging. When K3 is powered, it normally open contact close. 24 flows to slow the with curl Y7. Y7 get power, so we have 3A plus action. This puts the process still price out. Function position. 3A only job is to eject the finished work pieces. D1 is the single to start ejection. It links 1A reduce to 3A plus, so the process doesn't break. Last action, 3A reduce. First, when 3A finish its cross-budding meeting switch is target. 24 white floors to solo with the wave course Y8. Y8 get power, so we have 3A reduced action. 2. When 3A reduce finish, the system goes back to its initial state. Now it's ready to take the next square deals price from the manager and start the whole process again. This is cyclic operation. 3. 3A is the last step of the whole process. It resets the third so the system can keep working non-stop. To make sure the system works safely and doesn't break, we have 3 case design. First, for example, when K1 is poured, it normally closed contact open, so 1A plus and 1A reduce can't happen together. Then same rule applies to K2 and K3. This ensures only one action happens at the time. 2. The normally closed contact of C0 makes sure the system only started when our ports are in the digital position. This avoids risk like if a cylinder is still extended, the system won't start. 3. Every have 2 proximity switches. For example, A0 checks when the cylinder is detected and the A1 checks when it's extended. This way, even if one switch had a problem, the other can still work, making position feedback reliable. This is knowledge point. According this exercise, we have 3 sides to remember. Pneumatic side, electronic side, system side. Now we can look another thing. This is my author. Thanks for your listening. Goodbye.